Okay, let's talk about how do we use this Pythagoras theorem that we've learnt just before in the last video. Well, it's all about triangles. Let's just say that I have this particular triangle. I know how long it is across the base, I know how tall it is, but I don't know the diagonal. I don't know that hypotenuse length. You could imagine, really, that this, maybe it's a book. And you have your book here, and you want to know how long is the diagonal, right? And really all we've got left is, once we've rubbed out these lines, is just the triangle, right? So triangles are everywhere. You can make triangles out of whatever you're looking at, really. If you're into computer graphics, all of the models are all made up of just millions of triangles everywhere. Okay, so, well, we know the Pythagoras theorem. It is c squared is equal to a squared plus b squared. So which is A and which is B? The reality is, it just doesn't matter. I could call this side A, we could call this side B. So long as the longest side is C, you'll be okay. Okay, it's important to remember that. C is always the longest side. So we're going to substitute in the values that we have for A and B. And we're going to say that x squared, because that's really what I'm looking for, my length of C, my hypotenuse, is equal to 4 squared plus 7 squared. I can do those either by doing them by hand or in my head if I know what my times tables are. I'm going to get 16 plus 49. Once we have that, I can add them together, 65. And what I have is I now have my x squared is equal to 65. Okay. Is my calculation completed here? Well, it's not. I wasn't being asked what the square of x was. I'm being asked what x was. So how do I get rid of the squared part? Well, I need to do some division. It's a very special kind of division. Okay, and in fact, we refer to it as a square root. So the square root of x squared will give me just x. And that's what I'm looking for. So because I'm going to do that on both sides, I need to find the square root of 65. So the square root of 65, we'll grab our calculator and we can put in this button here, the square root button. 65 is equal to, well, I'm going to do some simplifying. I'm going to round off a little bit here. I'm going to round that off to 8.1, just to one decimal place. Okay, so that's how you do it. That's how you do these sort of questions with triangles and Pythagoras. If you know 2 of the lengths, you can work out the third length. Let's try another one just so that we got another example here. All right, here is our triangle. We've been given one of the sides. We've been given the hypotenuse, and there's the base we don't know. We've called it y. I don't know why, it just is. So we know our formula. You should always write your formula. C squared equals A squared plus B squared. I could probably get rid of that number there for the time being. Okay, so I'm going to then substitute in the values that I have. Okay, so I know that the longest side, that is going to be my C value. I know C is that. I'm going to just call this, I don't know, I'll call this A, that'll be fine. Which means that our B value really is this Y value. So let's substitute in the numbers that I've actually got. All right. So I'm going to substitute in 14 squared is equal to 8 squared plus something squared. I don't know. I ask myself my normal questions. Is my unknown by itself? Well, it isn't. My unknown has got this 8 squared being added to it. So to remove that, I'm going to take 8 squared from both sides. And I'm going to have 14 squared minus 8 squared is equal to y squared. Okay. Well, I can do some of this because now I've just got some numbers that I'm dealing with. So we'll do that. We can figure out what is 14 squared, and we can figure out what 8 squared is. I can take them away from each other, and I know that it's 132. And once again, I need to find the square root of both sides. My y my y squared goes to y. My square root of 132 will be 11.49, and just because we had some measurement unit in the question itself, I need to make sure that my answer has that unit of measurement. We don't normally write it so that our unknown, our y in this instance, is on the right-hand side of our equation. We want to rewrite that so that the y is on the left-hand side. And that's the answer. That's how it's worked out. Now, sometimes with these Pythagoras questions, you won't even be given the triangle. And you're going to have to actually come up with what this drawing might be. It might have a word question. So let's have a look at one of those, because you're going to get them and you'll need to know how to tackle them. Here we go. The hypotenuse and one side of a right-angled triangle are 450 centimeters and 3.4 meters respectively. Find the length of the third side in centimeters correct to the nearest whole number. Okay, so we've got some issues with this here. Namely, we have to make sure that our answer is going to be in centimeters. That's really important, which is fine for one of the measurements, the measurement of the hypotenuse. That's fine. But this measurement right here of 3.4 meters, that's a tricky one. Not really, I can't use it. I'm going to have to change that. So I'll need to do a little bit of calculation. I'll need to say 3.4 meters into centimeters. Well, I'm going to end up multiplying it by 100, and I'm going to have that's 2. That's the wrong number. 340 centimeters. So I'll need to make sure I use that as my my measurement when I do the calculations. Okay, I need to draw the actual drawing. I know I'm dealing with a triangle. My hypotenuse will be 450 centimeters. One of my sides will be 3.4, and then I'm going to have an unknown side, which I'm just going to call A. Okay, now that I have my triangle drawn, it's just the same process that we did before. Okay, write down your formula. Interestingly enough, and I haven't talked about this yet, but if you're good with your algebra, you can actually write the formula to make A the thing, the subject of what you're looking for. And in fact, you can even do it a step further than this line here. If you really know what you're doing, you could write A is equal to the square root of c squared minus b squared. And that will give you exactly what you're looking for, this A. I didn't use that, but that's okay. You can. All right, so let's have a look at what we did here. I substituted in the values that I had. There's my 340 that I figured out I needed because it's got to be in centimeters. I then do those calculations on my calculator. I don't want to do those by hand. I do the subtraction. I get 86,900. Because that was, of course, for a squared, I now need to find the square root of both sides. And I'm going to round it off to the nearest centimeter, 295 centimeters. So, and then, because it's a word problem, you have to have a worded answer. So the third side will be approximately 295 centimeters long. Excellent. Well, see, that's easy. Word problems are easy enough as well. However, sometimes, we'll do one last example. Sometimes the word question is a problem. There'll be a story involved. Let's have a look at this one. A fire on the 12th floor of a building. Oh, okay, it sounds dangerous. I've got to make sure you can read that. I don't want to have my face in the way. A child needs to be rescued from a window that's 20 meters above the ground floor. If the rescue ladder can be placed no closer than 6 meters from the foot of the building, what is the minimum length ladder needed to make a rescue? And answer correct to the nearest meter. Okay, so I've got to think about this. What is the important information here? Well, I know that the window to the ground is 20 meters. So window to the ground is 20 meters. And from the building to the ladder is 6 meters. So I can start to actually build up this idea of what this triangle will look like. Then let's have an attempt at that. Hopefully you can remember enough of this to see. So the drawing that I came up with looks a bit like this. It's not a neat, just a triangle. I was representing with the green line in the vertical that this is a building and it's probably higher, so it kept on going up. And the ground is definitely longer. And so I've represented my ladder in a different color to show that, yeah, that's where the ladder would need to be. It needs to be 20 meters and it's 6 meters away. So once I've got my triangle, same process. I will write down my formula. I will then substitute in all of my values. I'll calculate what I can to the point where I'm like, okay, well, I've got what x squared is. Now I need to find my value for x by doing the square root of that value, which is 20.88, which is about 21 meters. And of course, because it is a worded question, it needs a worded answer. So the ladder needs to be at least 21 meters long. Okay, so that's lots of examples of how you would use Pythagoras' theorem when you are solving just problems, including word problems, and problem solving is important to think about where the triangle is. What are the sides of the triangle? Can I represent it graphically? They're all very important things.